Okay, we're looking at the exam, and I'm going to start filling things out. My last name is Bannon. First name is Ron. And you put an email address down here. And then I'm going to sign it. Basically says I'm not going to cheat in the exam. And let's take a look. All right, so, I always say that, one step at a time, and I want to make sure you understand that this is important. You're able to do problems of this nature. They're not terribly difficult, but if you're struggling with this, I do recommend you get help, all right? So they say the point 3, comma, minus 4. So if I did that, it's going to be 1, 2, 3, and then minus 4 is over here. And that point's right over there. I'm going to put the terminal side down. I'm going to put the angle theta in now. This is the angle theta, all right? So looking at it, I know what x is. X is 3. I know what y is. Y is minus 4. And I know that r squared is equal to x squared plus y squared. R squared, well, x squared is going to be 9, and y squared is going to be 16. So r squared is going to be 9 plus 16, which is 25. So r, which is going to be greater than 0, is the number 5. And now I can start writing things down now. I can write the sine of theta down. I can write the cosine of theta down. I can write the tangent of theta down. The sine of theta is going to be that minus 4 over 5. The cosine of theta is going to be 3 over 5. And the tangent of theta is going to be minus 4 over 3. And again, you would need to know the definitions of those functions to know that. I'm going to write down the reciprocals, which is the cosecant, which is going to be minus 5/4, secant, which is going to be 5/3, and the cotangent, which is going to be minus 3/4. All right, that was the question. That's the answer. Let's go to the next one. And it says, for what values is the cosecant not defined? Well, just to give you a reminder of what we did, we looked at the sine function. The sine function looks like this over here. And then when you did the reciprocal would look like this over here. Now, someone says, where's it undefined? At these asymptotes. And between 0 and 2 pi, there's going to be 3 numbers. So let's write this down over here. So one of the numbers is going to be where theta is equal to 0. This is in radian measure, by the way. The other number is going to be pi. And the other number is going to be 2 pi. All right, that's done. So there's 3 places where it's not defined on the interval. Oh, you know what? They didn't put 0 in. I got to erase that. Only 2 places, by the way. So let's put this over here. So theta, I just noticed that, all right? Let's keep moving. This one's a multiple choice question, and looking at it, I want to try to visualize what they're saying over here. And they say the sine of theta is 1/2, but it terminates in the second quadrant. So I'm going to say, looking at it, I'm going to say something like this over here. This is where theta is. And I'm going to say there's a point over here. And I know that, let me just write this down, x, y, and r. I know the r is 2, the y is 1. Let me remind you, x squared plus y squared is equal to r squared. Well, I don't know what x squared is. Y squared is going to be 1, and r squared is going to be 4. So x squared would equal 3. Now I'm looking at the picture. I know the x is a negative number, so it's minus root 3. And again, the y number is 1. All right, so let's write this down. So the sine of theta is 1/2. I know that much. They want me to evaluate this, though. So I know the cosecant of theta is going to be the number 2. The cotangent of theta, right? Well, it's related to 1 over the tangent of theta. And again, you should know the tangent of theta. Tangent of theta, looking at it, is going to be 1 over, let me write this down for you. Tangent of theta is going to be 1 over minus root 3. So what's its reciprocal? Minus root 3. So what do they want to do? Multiply them together. So what are you going to get? The result of this one over here is going to be minus 2 root 3. Time to look at the key, and do I see that? And I do. It's A. Let's go to the next question. Again, looking at these things over here, again, if you're confused by the question, I would skip the question. And also, if you're confused by a question, you really need to start thinking about spending more time with the homework, all right? So let's say complement, supplement. So the problem with this students, I don't know how to do that. And the thing is, it's a mixed number. So I'm going to say 90 degrees is the same thing as 89 degrees, 59 minutes, and 60 seconds. And I'm going to say 180 degrees. I want to write as a mixed number, by the way. Just doing complement supplements. Is going to be 179 degrees, 59 minutes, and 60 seconds. All right? What are we going to do over here? To get the complement, what I got to do is I got to subtract away, I'll write this down for you, that number. So it's 23 degrees, 33 minutes, and 24 seconds. And we're going to subtract this away to get the complement. So the complement, I'll call it C, is going to be, it looks pretty easy, the arithmetic over here. It's going to be, let's see, 66 degrees. I'm taking 23 from 89. 33 from 59 is 26. Let me see if I did that right. 6. Yeah, I'm doing it right. And 24 from 60 is 36. So I'll put a little box in this one over here. This one's done. Let me do the supplement. Doing really the same thing. Subtracting 23, 33, and 24. What do you get there? Let's see. 156 degrees. This is supplement. And let's see what you get there. You get 26, and then you get 36. All right, put a little box in that. Call that done. Let's go to the next question. The next question says, use the picture as a guide and, label 5 points. And let's just go through that. I'm going to put the begin down for you. Again, if you can do it, that's fine. If you can't, write it down. You can get x equals, pi x equals pi over 2, and x equals 1/2. Let me do the end for you. That's going to be pi x minus pi over 2 equals 2 pi. Forgot to put the x there. I get to multiply both sides by 2. You get 2 pi minus pi, 4 pi. And then you get 2 pi x equals 5 pi. I'm going to divide by 2 pi, you get x equals 5/2. So if I were to put a table down now, and I'll tell you what my table would look like, there'd be an x over here, and I'm going to put y down. Would you understand that y is actually equal to f of x? And I'm glad I have a picture because it helps me a little bit, right? So I got the beginning, it's 1/2, and the end of it's 5/2. Now the middle between that, add the numbers together, 6/2 would be 3/2. The middle between 3/2 and 1/2, add them together and divide by 2, you get 2/2. So I'm going to start to say, it looks like a pretty easy counting problem. 1/2, 2/2, 3/2, 4/2. What goes over here should be relatively simple, by the way. And what are you doing over here? The first number evaluates to -3. The second number evaluates to -1. The third number evaluates to -3. The second, 1, 2, 3. The fourth number is -5. And the last one's going to be -3. Now what I want to do is I want to go to the picture, and I want to label these points on the picture, by the way. All right? Now someone says, what's easier for you to find? It's the whole numbers. I shouldn't say the whole numbers, the integers. So -3. So I'm seeing -3 here, and I'm seeing -1 here, and I'm seeing -5 over here. All right? So I think I'm ready to plot these points for you. This point over here is going to be 1/2, comma, -3. Let me do this point over here. It should be relatively simple, by the way. This is going to be 2/2. I'm just going to write down 1, -1. Put the next point down. And again, I'm looking forward to seeing these things over here. That's 3/2, comma, -3. And then the next number is going to be this one over here. That's 4/2, which is 2. And it's going to be -5. And then I get this one over here, which is going to be 5/2, comma, -3. Now, by the way, I can put this point down too if you want. Again, it's there. If you want to put it down, you can. That'd be another half up, which is 6/2, which is 3. And which can be 3 minus 1. I can also put this point down if you want. It looks pretty easy to do, by the way. It's going to be 0 minus 5. I could put this point over here. What's that point going to be? -1/2, -3. And I can put this point over here. And what's that going to be? Well, -2/2 or -1, -1. All right? Now, granted, I don't want to forget what they asked me. They said use the provided graph as a guide. Find the period, amplitude, and the 5 characteristic points. Well, I did find the 5 characteristic points, but I want to put the period down now. What's the period going to be? It's the distance between these two values which is going to be 4/2 or 2. I got the period down. Let me put down the amplitude. Now, if you looked at this thing over here, this thing, the top of it's -1, the bottom of it's -5. The distance between those two is 4, and half of 4 is going to be 2. So the amplitude is 2. All right? So we're 5 points. We got the period and amplitude, and the graph was helpful. All right? So let's look at number 6. And again, these questions really, I'm not going to say it's exactly the same question in your practice problems, but it's almost the same question. So I'm going to try to visualize this over here, the line first. And the way I graph a line out, just take points, 0, 0, 1. That's an easy point. And the other point I'd choose, by the way, is, let's see, 4. Because if x is 4, you get -5. So I could do that, 1, 2, 3, 4, 1, 2, 3, 4, 5. So I'm going to say it's over here. And there's a line that goes through that. And again, reading through it, it says that, it's in the 4th quadrant. Now, what's in the 4th quadrant? Theta is. So what does theta look like? It looks like this over here. All right? So what do I know? I know what x is. We just did it, by the way. X is 4. We know what y is. It's -5. And I know what r is by doing this. X squared plus y squared is equal to r squared. What's x squared? 16. And then y squared is going to be 25. And we'll put r squared down. What do you get there? Let's see, 41, right? So I know r is the root of 41. A nasty number, but I can still write that down. Again, what's their question? The terminal side of theta lies on a given, find the values. Oh, 6 trigonometric functions. Let's write this down. The sine, this is going to be theta, of theta, the cosine of theta, and the tangent of theta. I'll do the reciprocals later, by the way. And this is going to be -5 over root 41. This is going to be 4 over root 41. And this one's going to be -5 quarters. I'm going to write down the reciprocals. The cosecant of theta is going to be minus root 41 over 5. The secant of theta, is going to be equal to root 41 over 4. And the cotangent of theta is going to be -4/5. I'm going to put a little box in this over here to indicate that's done. Let's go to number 7. And number 7 for a lot of students is difficult. It's an arithmetic problem. And if they don't know much arithmetic, it's going to be a little tough to do that. But I do know that the wheels on the bus go round and round. And if I thought about this over here, the wheels are going like this. All right? So I'm going to point out over here, if I did this over here, and I hate to make people dizzy doing this, that's -360. That's going to be -720, right? And then I'm going to go around one more time. And, another -360 on that one over there. What are you going to get? Let's see, -1080, right? We're almost there, by the way. And so how much more do you have to go? Well, if you're at -1080 and you want to get to -1140, you have to go, let's see, 20 and 40, 60. So I got to go 60 degrees more over here in that direction, by the way. So the problem is, what's the least positive, all right? Now, someone's going to say it's 60. It's not 60, by the way. I want to point out why that is. We have to go, again, when we're doing this over, we have to go counterclockwise, like this over here, to get to this one, right? Whoops, sorry about that. Let me go backwards. Let me do that again. We're doing this over here. And what's that going to be? Well, it's 360 minus 60, which would be 300 degrees. Let me circle that. Let's go to the next question. The next question says, if theta is 7 pi over 3, that's a strange number, isn't it? Let's write this down. 7 pi over 3 times 180 degrees. I'm going back to my first language, by the way, over pi. Pi's cancel off, and you get 7 times 60 degrees. All right? And someone says, I wonder what that looks like. Well, I'm still going to do that, the wheels on the bus go round and round, and I'm going to go 7 times 60 degrees. And I'm going to say that's really 60 degrees plus 360 degrees, all right? So that's 7 times 60 degrees. So you go around once, and then 60 degrees more. So something like this over here, all right? And you should know that reference triangle, it's a 60, a 30, and a 90. And again, it depends how you want to put this down. You can put 2 here, 1 there, and root 3 over here. So I know, let's write this down. I know the x is going to be 1. I know the y is root 3. And I know the r is 2. Now, what do they want to know cosecant? Well, I'm saying I know sine. That's going to be root 3 over 2. And that means I know cosecant is a reciprocal of that, which is 2 over root 3. All right, let's go to the next question. I guess with number 8. Number 9 and 10. There's 10 questions, by the way. And again, I'm looking at 10, and 10 is a multiple choice question. And it says, you know, x is an angle in the second quadrant. I'll put this over here. So I know x is that quadrant, but what I know about it is the sine of x is going to be 1 over 3. Now, by the way, since they're talking about x as an angle, I have to call this a and b now. So let's visualize that. And I'm going to say, you know, I know the y is 1. I shouldn't say y, should I? Because I can't. I called it b, right? Let's put this down. I know the b is going to be 1, and I know the r over here is going to be 3. And the a, let's write this over to the side, a squared plus b squared is equal to r squared. What's a squared? I don't know. What's b squared? It's 1. What's r squared is 9. So a is going to be, I'm sorry, so a squared is going to be 8. So the a is going to be, well, looking at it, it's in the second quadrant, right? So the a has got to be minus root 8. All right? So let me draw my picture in. And my picture is going to look sort of like this over here. This is the angle x. And I'm going to label the point over here. And the point's going to be minus root 8, comma 1. And I want to answer the question, all right? Question is the tangent of theta. And what's that going to be? Well, it's going to be 1 over minus root 8, or minus 1 over root 8. Now, granted, I got to look at the key and wonder if that is in the answer key, because maybe they simplified it, who knows? But I do see it right over here. So it's letter B. Let's go to the last one. Last one, again, it really comes directly from the problems that we give you in the notes. And you really have to practice, by the way. Sometimes you look at that, I don't know how to do that problem. But I do, and certainly I'm not going to say my pictures are terribly good, but that's the Earth, and then there's a satellite going around the Earth, all right? I have a picture over here. The Earth has a radius, and then the satellite also has a radius with respect to the center of the Earth. So the first thing I want to do is, Earth satellite, circular orbit, 3,000 kilometers above the Earth's surface. I notice a footnote over there, and the Earth is 6,400 kilometers. So the orbit's radius with respect to the center of the Earth, by the way, would be 3,000 plus, they said 6,400, right? And what's that going to give you? 9,400 kilometers. All right? And someone says, well, what's the formula? And certainly you need to know that. And it's going to be V equals R omega. All right? So it says an Earth satellite, circular orbit, blah, 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 complete revolution every 10 hours. So what I do know is I know the radius, this is the radius, by the way, is 9,400 kilometers. I'm going to put that down. What's the angular velocity? Well, there's over here. It says it makes one revolution every 10 hours. All right? Remember, this needs to be in radian, so I need to get rid of the revs. So 1 rev is equal to 2 pi, all right? And I think I'm ready to put the answer down now, and I'll write the number down for you. It's 9,400. Now, I see it to be divided by 10, so I'm going to say 940, all right? So I got this, and then I see, oh, there's 2, and there's a pi. I see those numbers. And what's the unit on it? Well, the revs cancel, and I get kilometer, this is V, by the way, per hour. Okay, let's put this down. And that's going to be what, 1,880, right? 1,880 pi. And again, you're not supposed to do arithmetic that you can't do. And multiplying by pi is a little bit difficult for most students. kilometers per hour. It doesn't look like an hour. There it is. And we're done. Thank you for paying attention.